So welcome to everybody to this second webinar of the basic project, and you have so many people considered the end of August, and the speakers are ready. We had a good interest also for the first webinar, and on the social of the project you can find information and link from the previous webinar. This is an EUFresco project, and thanks to EUFresco we can be all together and discuss about basic substances that are compounds or treatments that one day may complement or even replace some of the synthetic pesticide or other application for the control of disease in the field and after the harvest. And before to leave the floor to the speakers, it is my pleasure to introduce Valdisera Giovanni, that is the coordinator of EUFresco, for a welcome harvest. Welcome, Valdisera. The floor is yours.
Thank you very much, Gianfranco. Welcome, everybody. It's an honor and a pleasure to attend this second webinar. The first one was very informative for me. Just to add some additional information to what Gianfranco explained. So the project is coordinated by Gianfranco Romanazzi with the participation of experts from approximately 30 research organizations from 16 countries. There are several European countries, but also Australia, Brazil, China, Colombia, Egypt, Mexico, Tunisia, and Turkey. The project aims to gather knowledge and expertise that is fragmented and under-resourced, with the objective to take advantage of studies that are ongoing in different countries and to accelerate the validation of new basic substances, but also new uses of already known basic substances. But also extremely important, the project aims to raise the profile of basic substances as an environmentally friendly alternative to synthetic pesticide within the scientific community, the research funders community, and the policymakers community. Enjoy the webinar.
Thanks, Valdisera, for the excellent coordination of this network and for providing the opportunity of networking. And we can start the talks of the day with Professor Antonio Ippolito, that is a professor at the University of Bari. He's a big expert in post-harvest disease, and he will deliver a talk titled "Electrolyzed Water for the Management of Post-Harvest Decay on Fruit and Vegetables." Electrolyzed water is not yet a basic substance, but has some of the properties to be one of them, and we will explore within this project all the opportunities also to enlarge the number of potential applications just to reduce the environmental impact of activity and protect as better as possible fruit and vegetables. Welcome, Professor Ippolito.
Thank you, Gianfranco. I will start division. I hope it will be. Can you see the
yes.
presentation? Okay, thank you. Okay, thank you, Gianfranco. Thank you, Valdisera, for the introduction, and thank you to both of you that you are coordinating very well this kind of project. That is particular because we were invited in a way so simple. If you are working on this kind of substance, okay, you can join the project. So it will be for sure something very interesting for me, for us, for everybody of us to be part of this project. As introduced by Gianfranco, electrolyzed water is still not technology substance, still not implemented in normal control of post-harvest decay, but has the potentiality to be one of that. Also because electrolyzed water is made with the use of salts, and these kind of salts are included or can be potentially included in basic substance. Clearly, the introduction is always the same. We have to control fungal infection during post-harvest because we have to preserve a commodity that has a very high added value. Important pathogens are more important, if you want to say, than in the past, because now between the harvest and the consumption there is a very long time due to transportation, due to storage, transportation to long distance. So it is necessary to preserve the commodity, fruit and vegetables from decay. And the management of this kind of disease are well known, managed by the use of fungicides. They are very effective, but we know very well that there are some issues on their application. Public opinion doesn't want to find residues, and they accept, for example, 0 residues, or they accept very well the organic commodity because of the absence, possibly the absence of this kind of toxic substance. There are many alternatives, and research all over the world is very active in finding alternative to this kind of to the use of a fungicide. During post-harvest, during handling process, there are various steps, and in the various steps, for sure, one important step in which the commodity can be contaminated is the washing phase, especially for some kind of fruits. If you have, for example, one infected fruit with sporulation on that fruit, you can have the water is contaminated, and this kind of water can inoculate, in the real term of this word, can inoculate all the fruits, especially those wounded, that come after this contamination. So the washing water should be decontaminated. And as we know, about the compounds that can be used for decontamination, chlorine compounds are those very important because and widely used because they are cheap and also very effective. But we know very well that chlorine has some problems. The use of chlorine has some problems, especially for the production of bioproducts such as chloramine, dichloramine, trichloramine, that are dangerous for human, for animals, for the environment. So there are various alternatives already applied, such as ozone, but also ethanol, a mixture of hydrogen peroxide and peracetic acids, organic acids, various organic acids. And among these alternatives to chlorine, there is also the possibility to use electrolyzed water. The electrolyzed water is produced by the electrolysis process, in which there is the passage of an electric current through an electrolyte solution. So it means you need a salt, with subsequent migration of positively and negatively charged ions to the negative and positive electrodes. And after this migration, you have the production of the active species that are capable to reduce the population of the pathogen, and also have the capacity also to operate, to have an activity on the host. It's not only an activity against the pathogen, disinfecting the water, but also other possible mode of action are involved. The electrolysis process is made with a cell, electrolysis cell, and this cell can be provided by a septum, or can be without septum. If you have a septum between the two electrodes, you will have reduction from one electrode on the cathode and oxidation of substances on the anode. You have so production of oxygen, production of ozone, chlorine, different kind of hydroxyl ion, hydroxyl radicals, oxygen radicals, hypochlorous acid, and also peroxycarbonates and so on. So they, a lot of substances, a lot of reagent or reactive species are produced. Depends on the kind of salt that you are utilizing. If the cell is without the septum, you can have a mix of all these reactive species, and so this kind of water is called neutral electrolyzed water, NEW. And in our experience, we use the non-septum type, and but there are many publications on the use of acidic or slight acidic electrolyzed water or basic electrolyzed water. The mechanism of action of electrolyzed water are still not very well understood, but for sure there is a direct oxidation on the anode surface, because on the anode, I come back, there is a production of really a great quantity of reactive species, but there is also an indirect oxidation in the water, in the bulk of the water, because there is a, how can I say, an increase of these reactive species in the water by the time. In case of sodium chloride, that is the salt mostly used, the activity can be ascribed to the chlorine and its derivative. But if another kind of salt not containing chlorine is used, then you have other kind of oxidants that are capable to exert the same activity. Hydrogen peroxide, ozone, various kind of percarbonate, and reactive oxygen species. Electrolyzed water has been seen, it is capable to increase the sensitivity of the membrane to different oxidizing agents. So the same agent after electrolysis can be more effective than in case with no electrolysis process. And also it is capable to induce resistance in the host with different reaction. The literature is full of papers concerning electrolysis of water. And just an example, there are many papers just issued in this year, in 2021, on bacteria and against also fungi. So this means that the technology is gaining great importance and probably will become in the future an important technology to be utilized all over the world. Electrolysis process can have some advantages and also some disadvantages. For example, it is easily, among the advantages, it is easily produced on site. There is nothing to transport except the salt that are generally not expensive salt to be used as electrolyte. Is safe for the environment and for the operators. Electrolyzed water is just reverted in normal water after usage, so nothing to discard. Has a multiple mechanism of action. This means that there is no possibility of rising of a resistant pathogen strain. Operation expense is minimal, just electricity and some filters maybe to be cleaned, and it is capable, apart from the control of the disease and the pathogen, is capable also to reduce the amount of pesticide in water and also on the surface of the commodity. Disadvantages: corrosive to some metals and resins, can produce chlorinated bioproducts, but only if using salts containing chlorine. Its effectiveness can be reduced by the presence of organic substance. This is normal for every kind of sanitizer. And sometimes, depends on the salt, on the concentration, you can have also phytotoxicity. We started our activity some years ago, just making salt screening, but in the literature there are many papers concerning salt screening. There is so in this case, there is a great possibility to choose. For example, there is also a paper by Youssef that will be among the next speaker in this webinar. We tested some sodium salt, sodium chloride, carbonate, bicarbonate, sulfite, and also potassium phosphate, copper sulfate, and potassium sorbate. And the results were interesting, especially for those salts containing sodium, because after electrolysis, the activity of this salt was increased. For example, I want to say this: electrolyzed water by itself, without any addition of salt, is working, but the activity, we can say, is very slow. You can see here, after 2 hour electrolysis, that the water, tap water, after electrolysis was more effective than the water itself on penicillium digitatum, and also on decay incidence on citrus. The same sodium bicarbonate, great increase of activity with electrolyzation. Sodium bicarbonate, sodium carbonate, sodium sulfite also, it was effective by itself, but an increase of 50% activity after electrolyzation. And the best one was for sure sodium chloride, because chlorine is among the other reactive species capable to reduce the quantity, the viability of penicillin. But we said, as we said before, chlorine as the bioproduct that should be in some manner avoided. Same results were obtained when inoculating fruits with citrus fruit with this kind of electrolyzed or non-electrolyzed water. And the other substances, the other salts, copper sulfate and so on, not containing sodium, were not effective. There was no increase of activity, sometimes also lower activities, for example, sodium copper sulfate. So no increase of activity. So some salts are okay, some other salts are not fine to be electrolyzed. With a mathematical formula, we also tested that some salts, bicarbonate, carbonate, and sodium chloride had a synergistic effect after electrolyzation. Concerning the quantity, the amount of chlorine, for sure only with sodium chloride we have 150 dpi, milligram per milliliter of chlorine, whereas with the other salts, no increase of chlorine. This is important because, as we said, avoid bioproducts or chlorine bioproducts. And also the most effective substances increase after electrolysis with this salt. There was an increase of pH from 10.9 to 11.3, from 9.3 to 10.8, whereas in case of salts with no activity, the pH of the water after electrolysis decreased. This is a paper by Youssef and co-workers in which he showed that acidic electrolyzed water was more effective than alkaline water. So if there is this kind of, if you have this kind of cell, acidic water is more effective than alkaline water. The problem should be in case of you need a great amount of water, for example, in a packing house. Probably this kind of machine should be a very powerful machine, because I think it should be utilized acidic water and not alkaline water. As you can see, the viability in acidic electrolyzed water was around 0 in almost all cases, whereas with alkaline water, you have some survival of Penicillium digitatum italicum and Ulayense. This is a small scale trials where we started with this, and as I said, the electrolyzed water alone, tap water, it was effective in reducing the Penicillium digitatum population in water, but it was necessary 2 hours to obtain a good reduction of population and also a good reduction of infection. Whereas with the addition of sodium bicarbonate, after 30 minutes, we had very good reduction of population. So it's a question of time and so also energy to be spent to obtain this kind of result. We moved to large-scale trials in a packing house in Sicily, and in this case, we had a packing line with 12 tons of fruits, of oranges per hour. So fruits very important, normal activity in a packing house. And we used water that was already utilized for washing, so it was contaminated. Then we started electrolysis with a powerful machine. And the population, we measured hour by hour the population of penicillin inside the water. And after 1 hour, we had only 50% reduction of spore vitality and 34% reduction of fruit decay, because we dipped wounded fruit each time to see after 2 weeks the development of the penicillin, of green and blue mood. And so we had after 1 hour 34% reduction of fruit decay. But after 7 hours, the reduction was important. Population in this tank that had, I think, 500, 800 liters of water. So it's a very important packing line. Reduction of population was interesting, very interesting, and also reduction of fruit rot. But it were necessary 7 hours to obtain, so continuous application of electrolysis to obtain this kind of result. It means that it were necessary some hours to charge the water with reactive species capable to reduce the population of penicillin and so on, to reduce the population, the infection of fruits. Then we added the sodium bicarbonate at 1.25% in the tank. Why this concentration? It is very simple, because in the packing house they apply sodium bicarbonate by themselves with this kind of concentration. So we did not change anything except the fact that the water was electrolyzed with this amount of sodium bicarbonate. And what we observed, the population after very high value in 1 hour was almost completely reduced strongly, 90% reduction of population. And this population, although fruit flow of 12 tons per hour, was maintained very low. We have, for example, a little increase at time 28. Why? Because there was deliver past some fruits that were very contaminated, infected by penicillin. There was a little increase, but then again the population was maintained so low. During the process, the pH was around 8.5, 8.8, and the DPD, that means the amount of chlorine, was 0.31. So the no production of chlorine. From this point of view, is this was the reason why we choose not the sodium chloride but sodium bicarbonate. And also the infection of fruits was maintained very low, lower than at the end of the process, lower than 10%. That is acceptable, an acceptable percentage of commercial acceptable percentage of decay. Then we moved to the explanation of mode of action of this electrolyzed sodium bicarbonate, and we measured the spore germination of a penicillium and germ tube length, and we can say that electrolyzed water and salt alone were effective, but the synergistic effect was evident. Great reduction of germination and germ tube elongation after electrolyzation of the salt. Also, we measure reactive species, and the presence of reactive species evidenced by fluorescent microscope. And higher fluorescence means also high level of damage of the cell, and in case of electrolyzed salt, we had the higher staining of the cells. Mitochondrial membrane potential was also measured, and this was measured based on the ratio between red fluorescence and the green fluorescence. Red fluorescence that is present in the control, and green fluorescence that is present in the damaged membrane, and this value was low in case of electrolyzed salt. So the membrane following this kind of treatment was disrupted, and so entrance of different kind of antifungal substances. We measure also the induction of resistance, just measuring the phenylalanine ammonylase, peroxidase, chitinase, and glucanase enzyme as activity and as also expression, and we observed that PAL activity was always higher, peaking at 24 hours, and also there was a upregulation at 12 hours. And also we measured peroxidase, enzymatic activity of peroxidase, similarly to PAL. We had a peaking at 24 hours and an overexpression at 6 hours. Chitinase also showed a continuous increase of enzymatic activity and a relative expression, upregulation at 6 hours, not so different from the other treatment. And then glucanase activity that was not so clear after a little increase, after an increase at 12 hours, then the situation was not clear. And also there was no upregulation, but only downregulation. Probably an isoform for this kind of primer, we choose primer that linked an isoform not involved in this kind of activity. Also, we made a little trial concerning the reduction of pesticide amount in water with the dimethoate and phenexamide, and the dimethoate was reduced by 90% residues in the water, and also phenexamide by 37%. So oxidation can also reduce the amount of this kind of probably every kind of pesticide. If they are organic, organic pesticide, they should be reduced. So in conclusion, electrolyzed water proved to reduce spore germination, germ tube elongation, and mycelial growth of penicillium. In the literature, there are many examples against bacteria, as we said, and also other kind of pathogen of fresh fruit and vegetables. Is also capable, electrolyzed sodium bicarbonate, to induce an accumulation of reactive oxygen species in cells and reduce the mitochondrial membrane integrity, and so delay or killing the pathogen. It was also demonstrated the capacity of electrolyzed sodium bicarbonate to induce resistance, increasing the activity of peroxidase and the PAL activity, glucanase, and chitin. There are papers in the literature in which they show also other kind of enzymes involved in the host resistance, and so this kind of results have been confirmed in other fruits and vegetables present in the market. So as a general conclusion, electrolyzed water has potential to become a major technology, and Eufresco, in the Eufresco project, this will be further evidenced. We are using different kind of salt that are also already present in the basic substance. So the possibility to implement this technology is really real. For sure, we cannot say that with electrolyzed water we solve any kind of problem of post-harvest pathogen, post-harvest rots, but for sure its application as a further hurdle to reduce the development of post-harvest pathogen can lead to a practical results. And with this, I thank you for your attention.
Thank you, Professor Ippolito, for this very clear and interesting presentation. And I invite all the participants that want to ask questions to write in the chat or even to raise the hands. There is Valdisera Giovanni that wants to raise a question.
Yeah, thank you, Gianfranco. You have actually a couple of questions. So maybe they are naive, and I apologize if they are. The first question is, so you presented the use of electrolyzed water. I mean, from what I understand, the active principle are the ions. So my question is, can ionized gas be used? I mean, I think that the choice of water, it's an economic choice, but I also see advantages in using gases because you can pack the fruit with a modified atmosphere. So that's my first question.
Yeah, electrolyzed water, this kind of reactive species are produced in water, so you need electrodes. But there are other technology, for example, plasma, that in which you have some reactive species as very similar to this, and this gas. Okay, so this technology should be applied with water, but other kind of technology can be applied as a gas. And for sure, one limitation of electrolyzed water is that you have to apply this on fruits that have this step in the handling process, nothing else. Maybe, yeah, not only with this kind of step. Otherwise, you need, for example, as I said, ozone or plasma to obtain the gas with the reactive species.
Okay. The second question, it's so you demonstrated the damage for the pest, but I guess the ions also produce damages in the fruit. And so what is the impact of this treatment on the acceleration of the ripening and the life shelf of the product eventually.
Yeah, there are papers in which they demonstrate, we didn't do this, but papers in which they demonstrate there is no impact on the physiology, also because the activity is on the surface, is not penetrating. So if you have, for example, an infection already started, it's very difficult to control. You can prevent, for example, incipient infection at control, but not latent in infection. Yeah, there is, you can have phytotoxicity, but for sure, pathogens are more sensitive than fruits to these reactive species. So generally, depends on the concentration of salt. You don't have, normally don't have any kind of phytotoxicity on fruits.
Thank you.
Okay, you're welcome.
Okay, thank you. And there are other questions, but we can allow Professor Ripoll to relax for a while. We will have a general discussion, so all the speakers that claim for question, we will have a general discussion at the end, so we will be plenty of time to answer. Professor Ripoll will be plenty of time to answer to everybody. And in the meantime, welcome to all the people that joined us and the people that are following us on Facebook. So we can move to the second speaker, that is Pervin Kinay-Texer. She's a professor at the University of Hege. And Pervin, turn on the microphone and the floor is yours.
Okay.
The title of the presentation will be Use of Salts to Control Post-Harvest Decay of Citrus and Pomegranate.
Thank you, Gianfranco. I'm trying to share my screen, but I didn't see it on the. Okay.
At the bottom, there is a share screen.
I
Perfect.
Oh, it's okay now. Okay. Okay. Hi, everybody. Thank you for your attention. I will talk about the salt. Yeah, now. As we know, green mold caused by Penicillium digitatum is the most important pathogen on citrus fruit, and it caused a great crop losses, especially particularly rainy years, and it's still controlled by fungicide applications for many years. It continue, and now a new fungicides also using to control Penicillium digitatum, like fluoxetinool, pyrimethamine, and new combinations. But as we know, the residue problem and the resistant pathogen problem is very problem, and we need to search new alternative solutions because of these problems. And recent years, several alternative approaches have been studied for post-harvest decay control on citrus and pomegranate fruit. And some of them also minimize post-harvest fungicide. Salt and their solutions, their combinations seems a good basic substance for this purpose, and with many advantages. We will talk about this today. Some mineral and organic acid salts are classified as alternative basic substance and generally regarded as safe grass post-harvest for post-harvest control. In this table, Antonio also showed us this, like this table. Sodium carbonate, bicarbonate, potassium carbonate, potassium bicarbonate, and also two organic acid salts, potassium sorbate and sodium benzoate, are using for the post-harvest alternative food additives. Sodium bicarbonate and sodium carbonate, potassium carbonate, and potassium bicarbonate are very common food additives. We know them in our kitchen also. They are used for leavening, pH control, taste, texture, modification in the food in the process, and they also inhibit various plant pathogen, and they are not, as we know, they are not new compounds for the post-harvest control also. Especially carbonate salts, sodium carbonate and sodium bicarbonate were suggested to control penicillium moths on citrus, even 1920s. However, the use of these chemicals reduced because of the chemical fungicides, but now they are popular again because of, I mentioned the problems. What is the mode of action? They haven't any special mode of action. Louis is working very much in the subject, and he wrote in a paper the mechanism of the action of the carbonate salt against penicillium decay is not clear. However, we can say generally for the organic salt products, they disrupt the potassium or sodium ion balance within the fungal cell and causing to the cell collapse, and they cause spore and hypha to shrink and collapse by reducing turgor pressure. The effect of spore germination and germplasm elongation inhibition on the different pathogen, fungal pathogen have been also reported previous studies. Generally, we can say because of the ion balance, changing ion balance within the fungal cells. Sodium bicarbonate, sodium carbonate, potassium carbonate, and potassium bicarbonate are very popular ones, and they are most studied compounds on the citrus fruit. Their combinations with different alternative strategies like hot water and also some fungicide combinations work different groups. All these treatments with sodium carbonate and sodium bicarbonate also give a good control, especially green molds on lemons, oranges, and blue molds on the oranges. Mostly Similanix, Joe Similanix and his team, and Luis Palou, his teams worked too much on this subject. We can say, I can give some sample about these studies. They work with the potassium sorbate, Similanix friends. The influence of potassium sorbate on different pH levels they studied on the Penicillium digitatum, and they make some combination. They made some combination also different fungicides, and to green mold on inoculated fruit, potassium sorbate was very compatible. These fungicides constantly improve their performance. They suggested. And the combination of potassium sorbate and sodium bicarbonate was only moderate effect they found. In their paper, I took some graphs, as you see. They look at the green mold incidence in different temperatures, 25 centigrade and 50 centigrade water they used, and they combined with the potassium sorbate, and the effect is very clear when they combined with the hot water. The effect of the potassium sorbate also getting higher. In this graph also, as we see, they use also sodium bicarbonate and potassium bicarbonate as combination with the hot water, and the effectiveness was very high when they combined with the hot water. They looked also not just Penicillium digitatum, also sore rot pathogen, Geotrichum, the old name Candidum, new name Geotrichum citri auranti. They worked also with this pathogen, and Australian people, Cunningham and Taverner, also worked with the bicarbonate sauce and Geotrichum citri auranti. The same results they obtained as we see, sodium bicarbonate and sodium different doses of sodium bicarbonate when they combined with the 50-degree hot water, the effectiveness getting very higher. Sodium, they tried also sodium hypochlorite with sodium bicarbonate combinations. The higher concentration of the sodium bicarbonate, the effectiveness is getting higher, but as they said, there is some quality problems goes on. Some pictures on their commercial test with sodium bicarbonate, and they suggest they found green mold reduced 85% on lemons, and also when the hot water used 30 seconds time period, also the control of the pathogen is getting very high. For the sore rot is, as we know, is very important pathogen, and the control is just depend on the N1 fungicide, guazetine. Guazetine is now unregistered, almost unregistered for the use. Because of this, to find a new solution for this pathogen is very important. Sodium bicarbonate and hot water together also work very well to reduce this pathogen. In their commercial test, there is a picture. Also, they combined with the fungicides with sodium bicarbonate and also hot water combinations, and almost 83% decreasing in the fungal pathogens decay. Joe Smolenic and his team found sodium bicarbonate dramatically improved the performance of the imazalil. Is very important, I think, for this result. The combination of the sodium bicarbonate and imazalil result in the superior control both imazalil sensitive and resistance isolate. As we know, the resistance isolate is very very big trouble for the packing houses. For imazalil or TBZ, almost all the packing houses, they trying to eliminate them. The addition of the sodium carbonate to the imazalil solution raises the pH, and this is considered to be least partially responsible for the increased efficacy imazalil. They suggest for this result. It's very important results, I think. From Australia, Cunningham and Taverner worked with the Geotrichum citri auranti. Geotrichum citri auranti pathogen cause sore rot, and they tried bicarbonate solutions with the imazalil and TBZ combinations, and when they combined with the fungicide with also lower dose of the bicarbonate, it give very good control for the pathogen control. Oh, sorry, I made a mistake. Yeah. Also, they draw an attention about a good point when combining with the imazalil-based fungicide carbonate salts with rise pH of solution. Imazalil become less soluble in an alkaline environment, and so agitating tanks is needed. As we know, salts, especially sodium salts, regulate also pH level on solution, but we have to check our solutions for the pH level. It's work both sides, so it can be affect also the efficacy and also fungicides itself. Sodium bicarbonate mostly alkaline solution. Because of this, it's regulate also pH level on the solutions. Many packing houses also use for just sodium bicarbonate or bicarbonate solutions as a pH organized good pH. This is my students, my master students study. We work with the also Geotrichum citriauranti. We tried sodium bicarbonate 1% and 2% and combined with the guazatin combinations, and we also obtained almost the same result. Sodium bicarbonate plus guazatin gave the best result. On pomegranate fruit, on the post-harvest stage, phylloxanil is working very well, but as we know, we need also alternative control strategies and food safe alternative strategies. Sodium bicarbonate and different the other salts also worked on pomegranate by Luis Palou, and they found potassium sorbate most effective additives as the most effective additives. They also made some combinations. The combination of the potassium sorbate 3 minutes in the 3% solutions at 21 degrees, and also combined with the controlled atmosphere storage was the most effective combinations they found. Also combined with the heated phylloxanil, and they suggest the integration of the potassium sorbate with controlled atmosphere storage for the alternative to synthetic fungicide on pomegranate post-harvest studies. And Tavernier and Cunningham said carbonate salts can increase the weight loss. It's very important. As a plant pathologist, we always think about the pathology and decay incidence, but the physiology of the crops is also very important. If some treatments increase the weight loss, so it's get also loss quality. Due to it will be use lower rates until experience is gained, they said. Because of this new studies we will need. And their work, so they suggest significant inhibition of the imazalil when combined with the azidolas 0.5% sodium bicarbonate. for the combination they suggest. And Simulanic teams demonstrate the mild heating like 45 degree, and the addition of the sodium bicarbonate, the effectiveness of TBZ was significantly enhanced. This treatment also improved the control of TBZ resistance isolate of green mold. It's also very important result for the packing house owners. Briefly, we can say for the studies suggest the potassium, sodium salts have potential as environmental product and non-toxic post-harvest fungicide against soil rot, green mold, and blue mold incidence on citrus and pulpy suggests for the commercial use for the packing houses. These are new results and it's still going on. We tried different sodium bicarbonate doses and combined with hot water, and also we found hot water combined with the 1% sodium bicarbonate very successful results. It gave very successful results. This is the picture. As we see, the result is very good. And we are working also banana and pomegranate, but it's still going on. They are my also master studies is going on. So why we use these salts, these food additives? Just it's my briefly I can say because we can use it very easily find in the around, and very cheap when we compare to the other especially for the fungicide, and they compatible to use other post-harvest treatments, even having a synergistic effect, and environmentally friendly and non-toxic additives. Because of this, they have many advantages, I think. Yusuf will present about grape, but I would like to give some my experiments about sodium bicarbonate. Yes, it's working very well, but we tried to on the grape before harvest, but my students didn't tell us when he was working on the vineyard. There is no mixture in the pulverization machine, and when we went to the vineyard, we saw when he started to spray in the row, in the beginning of the row, there is no problem. But when we went to the empty row, there are lots of burnt berries, as we see. Because of this, salt solution should be mixed very well. Just I would like to say this. And thank you, Gianfranco, and all my friends. Thank you for listening to me. And I would like to also thank to Luis Paleo. He's here, I saw. He's working too much about this subject. I decided very quickly to give this subject. When I look at the literature, I saw lots of papers belong to him. I would like to thank to him. And if you have a question, you can ask to Luis Paleo. Thank you.
Thank you, Pervin. You had an excellent talk, and I'm sure that a lot of people will have questions for you. If somebody wants to ask something, can raise their hands or write in the chat. It was very clear. Luis did a lot of work, and you tried to summarize everything in a wonderful way. Just a question to myself, from myself. how much it is important, the salts, and how much it is important, the variation of pH according to your experience that the salts induce?
When you have, you have about 5 pH solution water. When you use the sodium bicarbonate, it almost neutral. I can say like this. It's very changing the pH of the water, and also it's affects the effectiveness of the your material.
Thank you. There are any questions other now, or you can ask later in the general discussion. I don't saw raise your hands. So thanks again, Pervin, and
Thank you.
we can move to Youssef Kamis that has a talk titled Pre- and Post-Harvest Application of Salts Against the Gray Mold of Table Grapes. Youssef, you can turn on the microphone and the floor is yours.
Thank you, Gianfranco, for giving me this opportunity to demonstrate our results and experience regarding the pre- and post-harvest application of salts against gray mold of table grape. I would like also to thank Antonio and Bervin for the nice 2 presentations that it make my mission now so easily, because after them, I think they mentioned everything about salts. So let me focus on the pre-harvest application of those grass and basic substances. So as we are talking about grapes, let's say the worldwide grape production is estimated to be almost 77 million of tons, according to FAO last information available and statistics, from which table grape production estimated to be 27 million tons, in which China, the first producing country in the world, followed by Turkey, India, Iran, and Egypt. As we are talking about the grape, let's say that gray mold of table grape caused by Botrytis cinerea is the most important post-harvest disease attacking table grape, and this Botrytis cinerea considered to be the second place into the world top 10 pathogen all over the world, and it infects more than 200 crop species worldwide. From the horticulture products, table grape considered the most affected one. As you know, Botrytis cinerea is responsible for severe losses in the field and also after harvest, and it's considered to be the main problem for long distance transportation and during storage as well. For the biology, for Botrytis cinerea infection process, Botrytis cinerea is considered to be a necrotrophic fungus. It first kills the host plant cell and then colonizes the plant dead tissue. The minimum temperature is almost 0, and the optimum one is 20, where the maximum temperature is 30 degrees. So as Bervin talked about post-harvest factors affecting other pathogens in the infection process, the table grapefruit are more born to mold infection, and the correct choice of the fruit maturity at harvest stage is unimportant as other culture practice in the field. And as we know, the temperature and relative humidity together with other sanitation process is very important. In the field also, careful handling and other and the prevention of mechanical damage or phytopathological injuries is very important to reduce the decay even in the field and after harvest. As you can see in this two picture, the symptoms of gray mold in the field on the first one and even after harvest. Regarding this cycle, as we know that this fungus over winter as sclerotia most commonly in various moments on the ground or left hanging on the veins and its skin. And when the temperature and the relative humidity are favorable, the disease can be transferred. As other colleague mentioned about the chemical control method used in post-harvest control, let's have something special about grapes. And in grapes, we have something special because after harvest, we cannot do anything for the treatment unless we can use some silver dioxide in different ways, even if low or fast release after harvest application of treatment before harvest in different stage. Here we have the table where some chemical groups used to control botrytis cinerea on table grapes. And as our colleagues talked about the problems of pesticide, that public demand for fungicide product is highly recommended, and legislative restriction on the employment of the fungicide together with the development of resistance of many fungicide by major post-harvest pathogens, including botrytis cinerea. So what we need just to look to some alternatives that give the commercial fruit industry an opportunity to fill the gap of left by removal of conventional and traditional fungicide. So our demands are to have high efficacy salts and inexpensive as well as easy to fit within the current treatment protocol, like spray in pre-harvest before harvesting the crop. And the most important is that it has no negative impact on the fruit quality. So we are talking about the basic substances, as Baldessera mentioned, some salts already included in basic substances like sodium bicarbonate and sodium chloride. We are talking about some issues as mentioned even by Bervin now, that all salts have some issues and the problem like inconsistent results. Possible phytotoxicity are also mentioned by Antonio. Possible residue in the fruit, it needs more study to be confirmed, and the fungistatic effect, but not fungicidal one. This gives us the promotion to have the combination of alternative control means of grape. And as you can see here in a paper published by Gianfranco Romanazzi in 2012 and others, that they try to combine different treatment, and even they try to combine and to test different strategies. When I talk about strategies here, we talk about pre and post-harvest strategies, and even the combination between both of them. So we have several pre-harvest factors influencing the development of post-harvest disease, and the most important one is the weather and the location, cultivar and culture practice in the field, and the planting materials. So why we are talking and focusing in this webinar and in this lecture about pre-harvest treatment. There are some points that make pre-harvest strategy interesting practice to control or even reduce the post-harvest decays. The first one is the infection of fruit. As we know, it occurs in the field before the harvest, and it could be advantage to start the control at that point and stage. Next reason is the pre-harvest strategy decrease the fruit manipulation and subsequently potential damage and injuries are avoided. Lastly, additional contamination by pathogenic fungi present in packing house should be avoided, as Antonio talked about water decontamination in packing houses. So we are focusing on here on a research study cases. In the literature, we can see several and a huge number of publications talking about different salts and even natural basic substances against gray mold. And even from 2006, Antonio and his colleague published an article in Post-Harvest Biology and Technology talking about the pre-harvest application of salts. So what we are going to focus now is there is not too much publication about the different strategy. I mean, what is the different strategy when we applied these salts before and so the objective of this study was to compare the efficacy between different strategies of pre-harvest and post-harvest application, and also to get a better knowledge about the effectiveness of those salts on maintaining of grape quality profile. Here I show in this table the 8 kind of salts based on potassium and calcium chelate. So we did actually in vitro studies using different concentrations, started from 0.12 until 3%, and the in vitro studies and tests proved that potassium sorbate, carbonate, and bicarbonate, and from the calcium group, calcium chelate were the most effective for salts against the pathogen in vitro, as we can see here in these figures. And to confirm the in vitro studies, we also checked the germinated spores, and we have a correlation between the results from the in vitro post trials. After that, we validate those salts under artificial inoculation into plot of trials. Yeah, the artificial inoculation using 2 application treatment, sprayed or even immersed, and we have a good result comparing potassium sorbate and even calcium chelate. For sure, some salts like calcium silicate doesn't work under this treatment. And depending on the in vitro and artificial inoculation, we have selected the most important salts, namely potassium bicarbonate, sorbate, and calcium chelate, to be investigated in the field as pre-harvest treatment and after harvest as post-harvest treatment, and the combined between pre and post-harvest application. So these 3 salts were tested under field condition using 1% concentration, and the application was just 1 week before harvest. In pre-harvest experiment, untreated grapes were harvested and immersed for 5 minutes after harvest. Also, the third application was the combination between and post-harvest application as mentioned previously. Regarding the difference between strategy and so comparing to Ebridion in rural chemical control, we had an interesting and promising results even before and after harvest. But the most important was the pre-harvest application of these salts. As Baldassare asked the question regarding the quality of the product, and as a researcher, we are often focusing on the effectiveness of any treatment, and often we ignore even the quality of the product. For this reason, we investigated some physical and chemical probabilities, including weight losses, and compared to water control, we concluded that potassium bicarbonate, calcium chelate even reduce the loss of water, and berry color was also investigated, and potassium bicarbonate and calcium chelate improve the color of grape after treatment, especially in pre-harvest application in the case of potassium bicarbonate, and calcium chelate in the case of post-harvest treatment. Also, the TSS and tetrable acidity, we concluded that potassium bicarbonate at pre-harvest, it was the only case at pre-harvest application of potassium bicarbonate increased the Brix number of grapes. So we didn't have actually difference between different strategy and the different salts compared to water control in tetrable acidity. And the same was demonstrated for the ratio between TSS and tetrable acidity. And the last trial was a microbial profile on the fruit service itself. As you can mention, as we can mention here, that potassium bicarbonate, potassium sorbate, and also calcium chelate compared to water control, it reduced the microbial filamentous fungi assessed by log 10 CFU berries, and this result was correlated to the in vitro, artificial, and underfield condition. From these trials, we concluded that new strategies are needed and important, with the important goal of controlling gray mold of grape caused by botrytis cinerea. And one way to reach this goal is to use of effective salts, as we mentioned, that have low impact in the environment and it acceptable publicly and easy to apply and its cheap in price. Compared between different salts, we conclude that potassium bicarbonate is a cheap salt as compared to sorbate and calcium chelate, and may allow many growers to use them with the same equipment regularly used for chemical fungicide in the field. This kind of salts, together with other salts used in the literature, may meet the criteria of ideal alternative control means for controlling post-harvest disease in general, and in particular, gray mold of table grape. For sure, the use of the application strategy before harvest and after harvest to control post-harvest rots may represent a wider commercial implementation for alternative control means. At this point, I thank all of you, and your questions are welcome.
Thanks, Joseph, for the very interesting talk, and it complemented very well the one of Pervin Kiney and the one of Antonio Puerto. So everybody can get in with the video, and I'm sure that the speakers are ready to answer all the questions from the audience. So who want to start? Any question is welcome. If I remember well, somebody raised the hand earlier. Who want to start? You can raise a hand. The speakers are ready for you. If I remember well, Simona raised the hands. Yeah, welcome.
No, just more than a question is a general consideration regarding the electrolyzed water, because we thought about the different electrolytes that might be added, but much is done also by the composition of the electrode. So according to the composition of the electrode, there are different reactive species which are released into the water. So also this must be taken into consideration when standardizing this control tool that, in my opinion, is very interesting and will need further attention. Thank you.
Thank you, Simona. I don't know if Antonio, you have any comment about this?
Yeah, just to explain that we use the boron doped diamond that maybe among the electrodes are the best one as compared to iron, platinum, and other kind of electrodes. But in this field, there are also in this field the research is very active, and so it is necessary to consider the kind of electrode that can be utilized. Maybe this boron doped diamond, it means that are more expensive than other electrodes, but more effective because the species, as said by Simona, the species produced are important and very reactive and different from the other electrodes. That's this is really true.
Thank you, Antonio. Mario Picca.
Good evening. I would like to make a question to Professor Ippolito, and I'm curious if he measured the ORP potential of the solution that he has produced.
Yeah. We didn't measure this also because it was neutral electrolyzed water. It should have been around 1,000 millivolts, but we didn't measure.
Okay. And then the second one and the last, which was the purity of the bicarbonate of
bicarbonate? It was by a chemical company. It was I think 99%. But generally, bicarbonate is very pure.
Very pure.
Those sold by market American. Yeah.
Thank you very much.
Now is the turn of Luis Palou that raised the hands. Luis, if you want to show up. Welcome, Luis.
Hi, Luis.
Hello. Hi, good afternoon to everybody, especially a lot of friends that they are in this webinar. So it's always nice to see you around and to hear very interesting talks. And a little bit about what Pinay Pervin has said about the use of the carbonates to control citrus green mold and blue mold, especially in he has mentioned different works that we and especially Joe Smilenick did in California many years ago. So I just want to mention a little bit about the what is known about the mode of action, because she said that I mentioned in some publication that the mode of action is unclear, and it's probably because different aspects of the mode of action have been studied, but there is not a complete study giving the whole picture about the thing. So of course, there are some action of the salts, of the salt treatment as an aqueous solution acting directly into the pathogen. So the effects of the toxic effects of the salt on the structures of the pathogen, of the spores, of course. But I would say that it would be even more important, the effect of the salt treatment, especially if it's heated, when the salt is applied as a heat in hot water, like 40 something, 50 Celsius, then these indirect effects of the treatment into the host are even more important. Of course, pH is one of them. We know that, for example, bicarbonate, sodium bicarbonate application raises the pH in the infection court of the fungus to about 8, 9, while it's even higher when you use sodium carbonate, that goes into 11, something like that. And this difference in pH makes a big effect on the ability of the fungus to grow on those conditions. But at the same time, we know already that that is not the only mode of action, because if we use another salt, for example, a potassium carbonate or another salt, which the pH is exactly the same, the effect is not the same. So many other factors can influence this final, or let's say, whole mode of action. For example, even if the pH is the same, we know that sodium carbonate or sodium bicarbonate, specifically against Penicillium digitatum, are more effective than potassium carbonate or potassium bicarbonate. So this means that is another effect from the anion and from the cation also, when the salt is divided in an aqueous solution. By contrast, for example, potassium bicarbonate is more effective than sodium bicarbonate and against other pathogens like Botrytis cinerea, for example. No? So there is many other things. Also, work in Italy show some years ago that the carbonate treatment was able to induce the synthesis of phytoalexins by the host itself, by the orange itself. That was work by Dallewin, they are from Sardinia, no? I believe, and Bendini, Tullio works. So also more indirect effects of the treatment on the host. So of course, we know also that this kind of treatments cannot be compared to the fungicides, to Imasalil, in terms of persistence or toxicity of the treatment, because, for example, when you use sodium carbonate solution to control green mold, you will see that after 7 weeks of after 7 days of incubation, maybe the number of decay fruits has reduced, let's say 60%, for example, or 70%. But when you do another evaluation to the same fruit after 14 days, you will see that the level of disease has increased. So it means that the persistence of the treatment is not high, and also that with time, the treatment loses effectiveness. So this is always another symptom of the indirect effects on the host and not direct to the toxicity to the fungus. So that's that I wanted to mention, and of course to thank Pervin for all his references to our work and Joe's work also. Thank you very much.
Thank you, Luis. And this is the demonstration that so many novelties are still needed. Although research goes on, more we go on and more we are aware that we know few things. So investigations in those compounds that are not fully investigated and studied is more than welcome. So the idea of Valdisera and co-works to open a call on these basic substances is very important, and I'm sure the debate will go on in the next webinars as well. There are other questions from the speakers? If not, I thank all of you, and I give you the appointment to the next webinar that is on September 28th. It will be Alessandra that is now among us, and she's ready, and with other novelties. And if you want to see again this webinar, you can check the resources, the social media. It will show up. It is on indirect in Facebook, and several people saw it. So hello to everybody, and see you next time. Enjoy, everybody, and see you at the next opportunity. Bye.
Thank you.
See you. Thank you
Thank
to
you.
all.
Thank you all.
Thank you.
Thank you to all friends that I see connected. Thank you very much.
Thanks to all the speakers, the excellent speakers, for the excellent communication of the research results, and for giving an overview of the science.
Thank you, Gianfranco. Thank you.
Thank you. Thanks for giving us the opportunity to show our experience.